The last section of 11.2 is applications of arithmetic sequences and series. So you're going to be given word problems and you're going to have to figure out, are you going to use the general equation for the sequence, or are you finding the sum and need to find the general equation for the series? So this first question says Gloria accepts a job with starting with an hourly wage of $14.25. They're promised a raise of 15 cents per hour every 2 months for 5 years. At the end of the 5 years, what will Gloria's hourly wage be? So the first thing we have to figure out is, are you finding the nth term or the sum of n terms? So she's starting with an hourly wage of $14.25. After one raise, she's making $14.40. After 2 raises, she's making $14.50. I'll write this down because maybe you can't see it. So the first term would be $14.25. The second term would be adding 15 cents. And then we'd get $14.40. Then we'd add 15 cents again, and you get $14.55. The question is, do we want to find the sum of all these hourly wages, or do we want to know how much she's making at the end of 5 years? So the answer is, at the end of 5 years, we want to know what their hourly wage is, not the sum of all the hourly wages, so we're using this formula. So we're going to use AN is equal to the first term plus n minus 1 times the common difference. Okay, so let's see what we know. Well, first thing we have to figure out is how many terms we want to solve for, what the first term is, and what the common difference is. So we need everything. So the first term is easy. The first term is that she's making $14.25 when she starts out. We want to add her raises. She's getting a raise of 15 cents, so 15 cents is her common difference. Our question is, how many raises is she going to get? So let's look at this. She's making $14.25 when she starts. Then she's getting a 15-cent raise every hour. So she gets this raise every 2 months for 15 years. So every 2 months, if there's 12 months in the year, and she's getting one every other month, she's going to get 6 raises per year. 6 raises per year. So at the end of 5 years, if it's 6 raises per year and she gets them for 5 years, she's going to get 30 raises. Now this one's tricky. So we know that what goes in here is going to be 30. We want to add on 30 raises so that by the end of the 5 years, she started with $14.25, but she's going to get a raise after that first 2 months. So we will actually have 31 terms. And I do find this a bit tricky, if you're really trying to use this formula to its pure abilities, right, where you have to put in n minus 1, knowing that there's 31 terms because you're going to add 30 raises can be tricky. So, I mean, if in your work you just went, hey, to $14.25, I'm going to do 30 raises of 15 cents, that's great, right? You don't have to put 31 minus 1. But in reality, it is 31 terms because to that $14.25, she's going to get 30 raises. So there'll be 31 terms. But in reality, we just have to make sure that we're doing an equation like this. So we take $14.25 and we're going to add 30 raises of 15 cents. And she is making $18.75 an hour after 5 years with the company. All right, next word problem. This time we have a stack of telephone poles. In the bottom row, there are 30 poles, so on. In the second row, there are 29 poles, right? In the next row, there's 28 poles. What's happening? Well, we have 30 poles, then we have 29 poles, and then we have 28 poles. We have an arithmetic sequence. Now for this one, it says how many poles are in the stack if there are 5 poles in the top row. So for this one, are we finding an nth term or are we finding the sum of n terms? Well, since we want to know how many poles are in the stack total, we're finding the sum. So the first thing I do is I write out the summation equation. So a sum of n terms is equal to n divided by 2. times the first term plus the last term. All right, what do we know? Well, I don't really know the number of terms, but I know it's going to get divided by 2. I know that the first term is 30, and I know that the last term is 5. So I have to figure out how many rows are there if the first row has 30 and the last row has 5. Well, sometimes you have to use the other equation as well. So what if we use this equation? So any term can be found by taking the first term and adding the common difference a certain number of times. If we know that 5 poles are in the last row, and we know that it starts with 30, then we could figure out how many terms there are if we know the common difference. Well, to get from the first term to the second term, we minus 1, right? We keep minusing 1. So my common difference is minus 1. Now we can solve for n. So I'm going to subtract 30 first, and I end up with negative 25 is equal to n minus 1 times negative 1. Now I'm going to divide by negative 1. I end up with 25 is equal to n minus 1, and then I'm going to add that 1. And I end up with n is 26. So there are 26 rows of poles if we start with the first row having 30 and the last row having 5. And then we can find it. So we're finding the sum of 26 terms. So then we just plug this in. You end up with 26 divided by 2 times 35, which gives you 468 poles. So therefore, there are 468 poles in the stack. All right, so as you could tell, when you're doing applications of arithmetic series and sequences, you have to figure out which one we're talking about. Are they trying to find an nth term, or are they trying to find the sum of n terms? And then you're just making sure you have enough information to plug into the equations. Good luck.